The fourth domain of the CISSP is called Communications and Network Security. It covers topics that include secure network design principles, secure network components, secure communication channels, and mitigating network attacks. Communications between information systems are governed by protocols, which define how data is transmitted over a network medium. Due to many companies developing their own proprietary protocols, the International Organization for Standardization decided to create a common model, and it called it the Open Systems Interconnection or OSI model. Although the TCP model is the most widely used one, it is important to understand the OSI model layers and how it works. Nowadays the OSI model is used as an abstract framework that defines how protocols should function in an ideal world. The OSI model divides the networking tasks into 7 layers, which are physical at level 1, data link, network, transport, session, presentation, and finally application at level 7. These layers are sometimes referred to by their numbers, so it is important to know the number of each layer as well as its name. Each layer communicates with the layers directly above it or directly below it, or with the same corresponding layer on the other system being communicated with. When a system wants to send data to another system, data has to go through the 7 layers from application to physical. Headers and footers are added to the initial data before moving it from one layer to another, and this is referred to as encapsulation. When a layer receives the data from the layer above it, this data becomes the payload, and the layer adds its own header to this data. When moved to the next layer, the payload and header become the new payload, and the next layer again adds its own header. After reaching the physical layer, the data is transmitted according to the physical medium being used. When the data is received on the other device, this process is reversed, and is called de-encapsulation, where headers and footers are removed on each layer, as data goes from physical to application. The headers and footers contain information understood and required by their own respective layer, in order to be able to perform their purposes, such as switching information, performing checksums, or specifying used protocols. This means that the header added at the network layer is only meaningful at the corresponding network layer on the other device. Data at each layer has a significant name, where at the physical layer it is called bits, at the data link layer it is called frame, at the network layer it is called packet, at the transport layer it is called segment or datagram, and at the session, presentation, and application layers it is called data stream. In order to memorize the order of the layers, one can simply memorize a sentence that represents these layers, such as, "All people seem to need data processing," where the initial of each word refers to the initial of each layer up to bottom. The physical layer or layer 1, receives the frame from the data link layer, and converts it into bits to transmit it over the physical medium. At the receiving end, the physical layer converts the bits back into the original frame. The physical layer contains the device drivers that tells the protocol how to use the hardware for transmission and reception of bits. Standards used at the physical layer include the synchronous optical network, and the high-speed serial interface. These standards, along with the drivers, control the data throughput rate, handle synchronization, and determine whether to use digital or analog signals. Finally, network devices used at the physical layers include network interface cards, hubs, and repeaters.